In this video I'm going to show you an example of how to use Dijkstras Algorithm to find a route, or the shortest route, from one vertex to another. In this example we're looking at from A to G. Okay, so the first thing that we do is that we label vertex A as 0. You can think of this as it doesn't take any time to actually travel from A to point A. Okay, so we box it 0. So I box it off. Like so. Okay, and now I consider each of the edges coming out of A. So to get to B, it takes 5 hours, say, if these were hours. To get to C, it would take 6. And to get to E, it would take 4. Okay, and what I do now is that I select the least of these numbers. Okay, the least of these edges in this case. So that would be E. I box it off, and now I consider all the routes coming out of E that I have yet to travel along. I haven't got along EC yet, and 4 and 3 is 7, but that isn't better than 6. Okay, so I'm not going to cross 6 out and replace it with 7. Instead I need to look along EF. 4 and 7 is 11. I haven't got a value there, so I'm going to need to put it in. So now I look at 5, 6 and 11, and the shortest of these, or the smallest, is 5. So I box 5. And now I look at all the routes coming out of B that I haven't yet travelled along. BD, 5 and 3 will be 8, so I can write 8. Now 5 and 5 is 10, which is still not better than 6, okay? And out of 8, 6 and 11, the next to look at is 6, so I box it off. Now 6 and 2 is 8, okay? So that's another way to get 8. 6 and 5 is 11, okay, so I can write 11 for G. And then 6 and 4 is 10, which is better than 11. So what I can do is I can cross out the 11 and I can put in 10 instead. So I've found a quicker route to get to F. Now I look at 8, 11 and 10. The least of these is 8, so I box off 8. Now the only route coming out of D that I haven't travelled along is DG. So 8 and 9 is 17, but that's not better than 11. Okay, so I don't consider it. The next least vertex is F, so that's 10, so I box the 10. 10 and 7 is 17, which isn't better than 11. Okay, and the last to get boxed will be 11 at G. So in effect what I've done is I've found the shortest route from A, not just to G, which is 11, but to any of the other vertices. So the shortest distance to get from A to C is 6, the shortest distance to get from A to F is 10. The last thing I need to do with Dijkstras Algorithm is to trace my route back from G to A. So it starts from the right hand side at G. Okay, now 11 take away 5 is 6, so it had to have gone along to C, because 11 take away 7 is 4, not 10, and 11 take away 9 is 2, not 8. So now I'm at C. 6 take away 5 is 1, that's not 5. 6 take away 3 is 3, not 4. So 6 take away 6 is 0. So it must have gone A, C, G. Okay, so that was our shortest route from A to G, and its value was 11.